Hello and welcome to the third session on sorting and searching. Today we're going to discuss the merge sort. And the merge sort is very similar to the quick sort. It is based on dividing an array into different sections. As we've done with the quick sort, there are different approaches to writing the code. We're going to be using the top-down approach. Now let's look at the general procedure for writing the code. We will recursively divide the array into smaller subsections until we've reached the base of the array. Base meaning every individual element is separate. We then sort the different subsections and merge them to produce a sorted output. Now let's look at how the algorithm works. Let's say we are sorting a string or an array like this. We find the middle and then split this array into two parts. Right? We then further split these two sections into their own different subsections. And again, splitting these now into their subsections. And you can see we've now arrived at a point where every individual element is separate. Taking those, we can now sort and merge. So we take F and E, we can sort those and merge them. A and C as well, D and B remain separate. In the next step, we can sort D, E, and F, and A, B, and C. And then finally, we can take these two subsections and sort and merge them into the final sorted output. Right? Now that we know how the algorithm works, let's go ahead and write the code. Let's start a new file. And we start with #include stdio.h and then #include stdlib.h and #include string.h. Right, now we need some functions, so void, we'll call this split merge, and we're sending in *r int left int right. And then we have another function, we'll call that sort merge, and again sending in *r and int left, int middle, and int right. And finally, we have a print function. And we're sending in the array, so *r and the size. Now our main function. And here we have char r equal to, and then we have int count, which is equal to strlen of r. And now we call split merge. This will be for the first time, sending in r, 0 for left, and count -1 for right. Then we have the function print array being called with r and count. And then of course exit. That completes the main function. So now we'll write the next one, which is split merge. And the parameters coming in, *r, int left, and int right. And within this function, we're going to put printf statements, and this I'm doing mainly for your reference. So later on you can, by seeing these printf statements on the output screen, you can understand what's happening in the code. So printf, and now we compare if left less than right, then int middle equal to left plus right divided by 2. So now that we have the middle, we'll have another printf statement saying that we're going to call this function recursively. And then we'll call the function. So split merge with r left and middle. Okay. Then we'll have another printf. Okay, so by looking at this, you can already figure out that this is calling recursively split merge with left and middle, focusing on the section 0 to middle, so to say, and then this one is focusing on middle plus 1 to right. Okay, then we call the function, so split merge r middle plus 1 and right. After that, we need to call the next function, which is sort merge. Right, so here we say printf. Okay, and then we need to call that function. So sort merge, sending in the parameters r left, middle, and right. Okay. Then after this, I'm just going to put in a printf statement here saying exiting this function. And I'm going to mention instance here because remember we're calling this function recursively, so it's calling itself. Right, so there's going to be the stack involved here as well. So we just put an instance there. Right, so this finishes the split merge function. Next function is sort merge. Okay, and this one is bringing in the parameters r int left and then int middle and int right. Within this function, first of all, we need some variables, int L, R for right, and Z. And what we're going to do in this function is we're going to have temporary arrays to store from start to middle and then middle to end. Right, so we'll have int size 1, and this start to middle, remember, is going to vary, right, because middle is going to change. So size 1 will be middle minus left plus 1. Okay, so we're making sure we're including the middle there. And then int size 2 is equal to right minus middle. So these will be the sizes of arrays left ar, which will have size 1 size, and right ar, which will have size 2 size. Okay, then we have a for loop for L equal to 0, L less than size 1, L plus plus, and here we're just putting in these elements into left ar. So left ar of L equal to r of left plus L. So first time L will be 0, then 1, etc. Okay. Then we do the same thing for right arrow. So for R equal to 0, R less than size 2, R plus plus, and here we say right arrow of R equal to R of middle plus R plus 1. Okay. Then after this, once these arrays have been assigned the different elements, we will then reinitialize these to 0. That is L equal to 0, R equal to 0, and Z we will initialize to left. Why? Because now we're going to have a while loop while L less than size 1 and R less than size 2. And within this while loop, we are going to check if left R of L less than or equal to right R of R, then what we'll do within this if block is we'll assign to R of Z, okay, left R of L. So you see now we are assigning to the original array from the left array, right? So we are replacing what's in array Z with left R of L. So after we've done that, we'll increase L by 1, L plus plus, right? Now else, and within the else block, we'll say R of Z equal to right R of R. Okay. And then of course R plus plus. We also need to increase Z. So after the else, we'll put in Z plus plus. Then after this while loop, we'll have another while loop for any elements that are remaining now after this loop is done. So L less than size 1, that will be the first while loop to take care of the elements in the left array, right? So here we say R of Z equal to left R of L. Note that we're not reinitializing L, whatever L's value is, right? So that we get the remaining elements from left array put into R, right? Then you say here L plus plus and Z plus plus. And similarly, we have one for right array. So while R less than size 2. And here we'll have R of Z equal to right R of R, and then R plus plus and Z plus. Now you can change the logic if you like. You can play around with it, right? And come up with your own logic. Once this is done, we now have to just do the print array function. So void print array and pass in char star r int size. And within this, we will have int counter, and then say for counter equal to 0, counter less than size, counter plus plus. And all we need to do here is printf %c, comma, ar of ctr. And that's all. Okay, so now we're done with the code for all the functions. Right, let's run this and see the results. First thing to observe is that the data has been sorted. There are lots of print statements that can help us to understand what is happening in the code. So we place this on the side of the code so we can run through it. Okay, and I won't run through the whole thing. You can do that after the session, but I'll just run through part of it. So the first instance of split merge is called in main, right? At which point left is 0 and right is 5. We can see this statement in function split merge, and we calculate the middle, which is 2. Then we call split merge with array left being 0 and middle 2. When we do that, we go back into split merge, so you can see the statement in function split merge again, and we calculate a new middle, 0 plus 2 divided by 2, and so that is 1. Then we call split merge now with 0 and 1, right? And we go back into the function, and because 0 is less than 1, we calculate a new middle, which is 0 itself, and we then call split merge with the array 0 and 0. Now because left is equal to right, we don't get into this if statement block, but rather we have the message printed exiting split merge instance, which will now take us to the previous instance, this one, right? And remember that this is where we had called split merge with left and middle. So we're then going to call split merge with array middle plus 1, 0 plus 1, and right. Now because middle plus 1 is going to be the left, remember, and right is 1, and they are equal, again we won't go through the if statement block. We exit split merge, which brings us here, at which point we call sort merge. Right? And when we call sort merge, some reordering or rearrangement takes place. You can see we now have E in front of F, right? So after we finish with sort merge, remember control comes here, and therefore we have that message printed out, right? Which takes us out now of this instance of split merge to the previous one, which is this one. And of course, we had called it with left and middle, so now we're going to call with middle plus 1 and right. So middle plus 1, as you can see, is 2 and right is 2. Because they are equal, we don't get into the if statement block, but we exit split merge. And when we exit, we will come to this point and we will call sort merge, right? And you can see the values here, 0, 1, and 2. Left, middle, and right. Then when we go in there into sort merge, after we return, again we will come to this point. Control will move to the printf statement, print exiting split merge. And now you see that the array we have, when we go back to the previous instance, which is this one now, the array has changed from the previous call to sort merge. So now we have D in the front of E and F, right? And we are calling split merge, remember, with array, middle plus 1 and right. Okay, so I hope you get the idea. You can run through the rest of the code, right? And now to make it even clearer, let's look at a slide. So our first call to split merge was with 0 and 5. Remember, we calculated the middle 2, and then we called split merge with left and middle 0 and 2, which put another instance onto the stack, right? Now we calculate a new middle, which is 1, and then we call split merge with 0 and 1, right? Then we calculate a new middle, which is 0, and we call split merge with left 0 and middle 0. Because both of them are equal, we exit split merge, which brings us back to the point where we had called split merge. So we call split merge with array middle plus 1, which is 0 plus 1, and right, which is already 1. Nothing happens there because these are equal. We exit that instance of split merge and we call sort merge, right? That's where E and F, or F and E, are put in order, right? Now after calling sort merge, we will exit this instance and we will come here, right, where we call split merge earlier. Now we call split merge with R middle plus 1, which is 1 plus 1, 2, and right, which is also 2. Because they're equal, again nothing is done, and we come back to this point where we make a call to sort merge, right? After we make the call to sort merge, we exit this particular instance, which brings us back here, right? And here we call split merge. There shouldn't be a T there. And we are calling it with array middle plus 1, which is 3, and right, which is 5. Okay, now when we do this, because 3 is less than 5, we calculate a new middle, which is 4, and we call split merge with array left is 3 and middle is 4. Then, so now remember, left is 3, right is 4. We calculate a new middle, and that's 3. We call split merge with array left and middle. So left is 3, middle is 3, which means left and right are 3. Because they are equal, we exit this instance. We come back to the point where we had called merge, where we had called split merge, with left and middle, and we call split merge now with array middle plus 1. That is 3 plus 1, 4, and right is already 4. Because they're equal, we do nothing there in split merge. We come back here and we call sort merge. After we call sort merge, we exit this instance and control comes to this point where we call split merge with array middle plus 1, which is 4 plus 1, and right, which is 5. Right now, because they're equal, middle plus 1 is 5 and right is also 5, we do nothing in split merge and we make a call to sort merge. After which we exit this instance, which brings us to the point where we had called split merge with array middle plus 1, 3, and right 5. And then we call sort merge for the last time. And that's how we have the data sorted. Now, choosing a sort. So the quick sort is optimum because of speed, but because of recursion, that could offset the benefits. So you need to do a cost-benefit analysis when you're talking about sorts. Right? So if you have a less amount of data, for example, you have less than 100 elements, then sometimes you'd be better off just using a bubble sort. Right? So you need to weigh the costs and benefits, like I said, in terms of the speed and the length of the data, etc., in order to determine the type of sort you will use. Right? So this ends our session for today. In the next session, we will actually write code to sort strings and structures. Till then, take care, stay safe. Bye.